So in the second half of the class here, I'd like to have a look at what's coming up. We'll do a little pre-assessment kind of thing and talk a little bit about gravity. Here is the outcomes for this particular unit. Again, hang on to this. This will tell you what's going to be on the test. If you're still one of those people that doesn't know how to use the rings in your binder, it's high time you learn. Science students do that. It's what it's expected. Well, there's a lot of space. I put space in there in case people wanted to write in between. So here's what you're going to do. Students define the gravitational force constant G as a force per unit mass. And the weight as Fg equals mg. The acceleration due to gravity is derived from Newton's laws and determined in the lab. Okay, Cole, I need you to listen now. Students describe the normal force in terms of the mutual attraction of masses and draw a simple free body diagram. So a lot of what we did last unit is revisited, and basically everything that we did where we had like the horizontal force going one way and the friction force going the other way, everything is basically just turned, rotated, so now it's up and down. Okay, so everything that was going sideways now is now going to be thing forward. Cole, listen. Stop talking. Listen to me. I'm talking to you too, but you don't seem to be paying attention to me.
He's distracting my learning environment.
Cole, you will define the gravitational field qualitatively as the region of space around a mass where another point mass experiences force. Basically, can you say that? Do you understand what a gravitational field is? Diagram the Earth's gravitational field using lines of force. You're going to draw a picture, I'll give you a check mark. Define the gravitational field quantitatively as a force per unit mass. Quantitatively means like with numbers kind of thing, right? So you know that it's newtons per kilogram. Compare and contrast the terms mass and weight. Excellent example of that. Do you remember when Evan walked in and asked me how much I weighed? And what did I say? 800 newtons, because that's what he asked me. He did not know the difference between mass and weight. He was really asking me, what's your mass, right?
Yes.
Yeah. In pounds, which is actually a unit of force, which is actually your weight. Your
weight. If
weight.
If I asked you in how much do you weigh in pounds, would you still give me newtons or you?
No, I probably would have said it. Actually, what I probably would have done was got on my scale and said, I don't know, you'll have to convert this. Thanks for asking. Describe qualitatively and quantitatively apparent weight changes in vertically accelerating systems. When you get in an elevator, your weight changes. Your mass doesn't, but your weight does, depending on whether you're accelerating up or down. We'll talk about that. Derive the acceleration of gravity from free fall and Newton's laws. Perform an experiment to calculate G near the surface of the Earth. We will determine what G is here in Dauphin. What number should we get? 9.8. I've got these little plastic sort of balls, and they've got a stopwatch on them, and you let them go, and the stopwatch starts, and when it hits the ground, then it stops, and you can figure out what gravity is.
So you gotta do more laps?
We're going to do a lap.
Nice.
If you haven't turned in the previous ones, get them in. I got to start marking those. You will describe terminal velocity both quantitatively and qualitatively. You will define the coefficient of friction, mu. Guys, I need you to listen. Trying to tell you what you're going to learn. If you listen, you might learn it. Define the coefficient of friction, mu, is the ratio of the force of friction and the normal force. Okay, mu is this funny looking U thing here. It's a Greek letter M. Okay. Distinguish between static and kinetic friction. Compare the effects of the normal force materials involved, surface area, and speed on the force of friction. And I'm sure there is. Solve problems with the coefficient of friction for objects on a horizontal surface. So not only will we be doing free-falling objects, but before we had boxes sliding across tables where I gave you the FF, I am not going to give you the FF anymore. I'm going to give you a number that describes how rough the surface is, the coefficient of friction. I'm going to take that question that we just did and make it a little bit harder, take it back a little bit. Building on what you already know. If you don't already know it, you got to learn it. It's not going away. For sure, too. Okay, let us do this one and one more, and hopefully we'll get to Megan's. Let's have a look here and see how you did. There is no gravity in the vacuum. False! What do you think's holding the moon in place?
The vacuum.
Gravity.
There's gravity everywhere.
What do you think's holding us on orbit around the sun? Gravity.
30%.
False. There is gravity in a vacuum.
I'm looking good, boys. Lane, what'd you get?
It pulls, it doesn't.
You can't build it.
This is just a way for us to start a conversation. NASA has no zero gravity chamber.
Well, they get the.
Now, what did you see yesterday? Those of you that were here. I showed you a plane
Where they went into.
where they go up into space and they simulate zero gravity, but is it actually zero gravity?
I thought they had to.
It just feels like no gravity. Yeah, they are.
On the TV show.
Gravity is the same as air pressure. Please tell me you got this all right.
Nope.
Almost.
I got it right.
Oh, yeah.
Nothing at all to do with air pressure. False. Most of you got that. Good. Gravity pushes down.
Pulls.
How is it not? Push down. It's not pushing you down. Yeah.
Pulls you down.
Good job, Wayne.
Everything has.
Gravity is the same as magnetism. Hey, haven't they all been false up to now?
Yeah.
False. Gravity is not the same as magnetism. Amanda, you need to listen.
Magnetism's about metal.
Gravity in space is zero. I think we had this question already.
Depends on where you're at.
What do you think is holding the planets in place? Gravity.
You'd have to go pretty far.
Are you feeling kind of down about this gravity stuff?
Yeah.
Not really.
Ah!
Okay, now please tell me.
I got it wrong. Me too.
During a full moon, you know, because the moon is full,
It's
the moon has a higher gravitational pull, creating a higher tide, because there's more moon there, right?
There's just like shadow there.
Well, I don't know. Maybe it's like.
It's shadow like
Like the bigger the I put sure. The bigger the moon, like creating a higher tide. That's what got me.
We're good for
He's gone.
Gonna go cry in the corner for a bit.
There's
The moon is still all there.
There's just like
It's like me going, you can't see me. The moon is still there, you guys.
It's full.
When the moon looks like this,
Yeah.
it's not because some giant alien cookie monster ate 3/4 of it. It's still there. Okay, now please,
I like.
I might just quit here.
I wanted to pick D because it was just so good.
Please, please.
On feathers.
Okay. Pound of feathers, pound of bricks is the same thing. They weigh the same. They weigh a pound. Okay, now just because everyone has been like kind of false already, right?
Everything is
But
false.
the pulse, it doesn't stuff.
Black holes don't suck everything into them. True. Why is it true? Well, because are you something? Have you been sucked into a black hole recently? Are you currently being sucked into a black hole? No.
So this is semantics.
Here's how it works. And I'll explain more in grade 12, but basically it's like this.
So much gravity that speed of light.
Here's a star.
Now it's not a star.
Okay? Listen.
It's clouds.
Here's a planet out here. Said planet is orbiting said star. Star decides to explode and then become a black hole. Infinitely small. It has exactly the same amount of mass. It has exactly the same amount of gravitational pull, and said planet now orbits a black hole. I've simplified a little bit. That's how they find out where black holes are. They look for planets that are orbiting nothing. Now, if it were to get close to the black hole, like before when the star was this big, whoops, when the star was this big,
How big? How big?
right? If you went anywhere close to it, you would be sucked into there, right? But now you can get close to, there's that black hole down there now, right? There's nothing there, right? But now you're inside that gravitational pull, and you will get sucked into it. In other words, black holes only suck things into them that it would have sucked into before. It's just that now it's so dense, right? It's tiny.
It's so
Tiny. And I've sort of gone farther than I need to. But, yeah,
There's a black hole just like.
it's a collapsed star. It's an incredibly dense point of matter that has a gravitational field, but it's so tiny that it looks like things are getting
So it
sucked.
sucks something in that here will disappear then.
Basically, it just gets crushed out of existence. Infinitely dense. Okay, let's see. Okay, I'm a little bit worried about this one.
I actually got this one right.
Did you? Which of the following diagrams most closely represents the gravitational forces that the Earth and the Moon exert on each other? This diagram is not to scale, but keep in mind the mass of the Earth is about 80 times that of the Moon. Here I've got my Earth. Here I've got my Moon. Is this about the right distance, like scale-wise, do you think?
No. That's like I'd say right
We'll
on.
just say
Eh?
it's
That's like right on.
Really? Okay, here's what I'm going to do.
But in Mr. Graham, it'll be closer.
I will put the moon there, or the Earth there, and I will give 3 people. Any volunteers?
Yeah. Yeah.
You help me out, so.
I got it.
Okay, hold your moon where you think it should be in scale relation. Hold your moon.
I'll go there.
Hey, so excited.
Where are you going, Lee?
Matt Hall right here. Matt Hall.
One cake.
All the way down.
He's in the corner right there, and he's still not far enough away. You can come back. The moon is a real long ways away. I think it's 20 big steps. Okay. It's about 20 big steps. Is he coming back, or is he just, yeah, he's gone. Okay. So, true or false? True or false? Thank you. The moon orbits the sun, or the moon orbits the Earth. True. What's holding the moon in orbit around the Earth? Gravity. Which of the following diagrams most closely represents the gravitational force that the Earth and Moon exert on each other? The mass of the Earth is about 80 times that of the Moon. Which one is it? C. What did Newton say? For every action force, there is a, what's the word?
Reaction.
Equal! Equal! Equal and opposite. The forces must be equal to each other. Why then, Mr. Bennett, doesn't the Earth orbit the Moon?
I don't know.
Because the Earth is about 80 times bigger than the Moon. The forces are the
20
same.
big steps? I went all the way to
It's about 20, yeah, no. It's about maybe the entrance to the upper tunnel. Okay? The forces are the same, equal and opposite. Okay? Alright. You can bring the clickers away, and we will stop there for the day.
Yep.